Curiosity is what leads us to embark on great missions and make important discoveries. It's no surprise then when it came to name the latest rover to explore Mars. She was named Curiosity. Engineer Eric Blood and the team from NASA's Jet Propulsion Laboratory in Pasadena, California, have developed this special rover to explore the surface of the planet Mars, nearly 34 million miles away.
Behind me here is actually a full-scale replica of the Mars Curiosity rover. This is just past its one-year anniversary on Mars. We landed her August 5th last year, and she's been doing really great science ever since. And as you can see, she's not exactly small, very, very large rover, and we're pretty proud of her. She's been doing some pretty awesome stuff so far.
The Curiosity rover is a Mars science laboratory that is sort of like a living creature, exploring the surface of Mars. Curiosity can rove around and look at rocks, pick them up, and taste things to see what they are made of. She can even talk and listen with the engineers on Earth using her antenna. The way Eric and his team get the rover around on Mars is through a series of steps, using rockets and parachutes.
We deploy this giant parachute that slows us down. Then when we got really close to the ground, we use this thing called sky crane, which is basically a bunch of rockets behind the rover, and we lowered it safely to the surface already on its wheels. And that current system can only land pretty much what we already landed, at the size of Curiosity on Mars. If we want to start landing larger rovers with different payloads and more interesting science, or land in more interesting locations on Mars, that requires some new technology that we've not yet flown. I'm working on a technology that will let us land even larger rovers, or allow us to land those rovers in more areas on Mars. And the way we're doing that is we're testing this technology here on Earth and in the Earth's atmosphere, and basically pulling information from that test that will let us, that will give us confidence that we can actually fly this successfully on another planet.
Eric and the team test their parachutes on Earth and use math and formulas to predict how the same parachute will behave in Mars's thin atmosphere.
When we're flying through the Mars atmosphere to try to touch down safely on Mars, the key thing that we're using to slow ourselves down is drag. And drag is made up of three main things, and that's how fast the vehicle is going, the density of the atmosphere that we're flying through, and how well that device is at slowing ourselves down.
Density measures how many air or fluid molecules are in a certain volume. If you have a low-density fluid, air or gas, you're moving a lot less molecules out of the way and exerting less pressure. Instead, if you're going through a very dense gas, it will be harder to move your hands or to move a vehicle through that. The more dense the air or gas is, the easier it is to slow down because the gas pushes on the vehicle through a force called drag.
Mars is a much more difficult planet to land on just because the atmosphere is so much less dense. There's so much less of it there to slow us down. It's about 1/100th, just 1% as dense as Earth's atmosphere, so there's just a lot less of it, and we have to use it very, very carefully. Here on Earth, we have this very cushy atmosphere when the Apollo astronauts or the space shuttle's coming back. You can use that atmosphere a lot to slow yourself down.
To be able to explore Mars with the Curiosity rover, engineers and scientists work for decades on the equipment to collect all of this valuable data.
This last vehicle took close to 10 years to develop, to build, to launch, and now operate on Mars. For some scientists, they've been working on the Mars projects for their entire career, 40, 50 years, and they're still discovering stuff today. They're still seeing stuff in these samples and in the images that we're taking that they hypothesized, they thought about 50 years ago, and they're saying, here's the data that's actually confirming it.
Want to design your own Mars lander? Try the activity on the Curiosity machine.